Alright, in this video we're going to continue our review by taking a look at questions 5 and 6 from the review packet. They both involve finding missing terms when we don't know what the first term is. Question 5 has to do with an arithmetic sequence, and question 6 has to do with a geometric sequence. The processes are going to be almost exactly the same. There are just some small changes that have to happen, but both processes are going to have 4 steps. The first step is where we write our equation. where we write our equations. So for this sequence, since it's arithmetic, we're going to take the information given to us and we're going to rewrite this information so that it matches a general arithmetic formula, which looks like this. A sub n equals dn plus a sub 0. Remember, this formula you should have memorized, and you're not going to be able to take the test if you don't know what this formula is. So for the first one, let's go ahead and take the information. The 7th term is 28. That means that a sub 7 is the number 28. In this statement, the number 7, right down here, that's the n value. And I've got an n right up there in my equation. I also know that if that n value is 7, then 28 is the outcome, the a sub n value. So I'm going to go ahead and rewrite this equation as 28, which is my a sub n value, equals the common difference. I don't know what that is, but I do know that n is 7, and then plus a sub 0, which again, I don't know what it is. The only information I've been given is that in this first term, the n value is 7 and the outcome is 28, and I've put it into the general formula. Let's go ahead and try the same thing with the second formula that we've been given. We were given a sub 12, the 12th term, is 53. So again, they gave us some information here. They gave us the n value, and they gave us a sub n. So let's go ahead and fill those in according to this formula. A sub n would be the number 53. It's going to be d times the n value, 12, plus the a sub 0 that we don't know. So the first step is going to be to write these out as equations based on our general formula. Once we've done that, it's time to move on to step 2 of our process, which is where we actually solve for d. We need to find our pattern. And our pattern in this case is the letter d, and d is the common difference, which means the operation of subtraction. So we're going to be able to calculate d by doing subtraction, and this is what we're doing in our second step. I'm going to subtract the second equation from the first equation. So subtract every single piece of the second equation from the first equation. So let's subtract one term at a time. 28 minus 53, that's negative 25. 7d minus 12d is negative 5d. And a sub 0 minus itself is nothing. It disappears. Which means now we have an equation that has only the d variable in it, and I can get it alone by just dividing both sides by negative 5. Which means d is negative 25 divided by negative 5, so it's positive 5. Now that we found our d value, we're going to go ahead and figure out our a sub 0 value by plugging d back into whichever equation we feel like. It doesn't matter which formula we use. It could be either one of the 2 original equations. I'm going to go ahead and pick the top one just because the numbers are a little bit smaller. So I'm going to take the formula 28 equals d times 7 plus a sub 0, and I'm going to plug in the d value that I just found. D is the number 5. And since I just plugged in the number 5, I'm going to be able to solve for a sub 0. So I can do 5 times 7, which is 35, plus a sub 0, that's 28. And then I can subtract 35 from both sides, minus 35. So it looks like a sub 0 is going to equal the number negative 7. Now that I have done all 3 of these steps, all I have to do is the last step, step 4. Which is to write an equation, or generally, it's just to answer the question. So we just have to look to see what the question is in this problem and answer it. So this question says to find the first term and the common difference. If we take a look, I already found the common difference, so d equals 5 is part of my final answer. The only other thing I have to find is the first term, which is a sub 1. I have a sub 0, which is negative 7. So in the grand scheme of things, if this is a sequence of numbers, 1, 2, 3, 4, first term, second term, third term, fourth term, I need to find I have the 0 term, negative 7. I need to figure out what number comes next. And in order to move forward in the sequence, all I have to do to get from number to number in the sequence to move forward is I just apply my common difference, which is plus 5. So to move forward from negative 7, all I have to do is add 5, and I get the number negative 2. And that's how I would move from term to term. So we've answered our question there. The other way that I can do that, if I was interested, is I could create my general formula, a sub n equals dn, so 5n plus a sub 0, which is the minus 7, and then I can plug in the number 1 for n. So 5 times 1 minus 7, which is 5 minus 7, which is negative 2. Either way, you get the exact same answer. So let's go ahead and take a look at question 6, which is almost exactly the same, except question 6 says that we have a geometric sequence, and we want to find some missing terms now. So this formula is going to happen almost exactly the same. Our first step is still going to be to write equations, except we are going to have to use the geometric general form this time. And the geometric general form, a sub n, is the first term, a sub 1, times r to the n minus 1 power. So this is the general form that we're going to have to use this time. And we're going to start our process the exact same way. We're going to start by writing our equations so that they fit into this general form. So let's start with the first piece of information we've been given. A sub 7 equals 243. I'm going to go ahead and rewrite this so it fits into the equation that I've got up top. And we're going to be able to fill in the same pieces of information that we just did in the last problem. In this example that I have right here, they gave me an n value of 7, and there's an n in my equation right here. They also told me what the a sub n value is if I plug that in, and a sub n is right here. So I can go ahead and plug in what I know. 243 is my a of n value, and it's going to equal a sub 1, which I don't know, times r, which I don't know, and 7 minus 1 as an exponent, because I do know that n value is 7. So if we simplify this, we can actually do the math 7 minus 1, and we know that 243 is a sub 1 times r to the 6th power. So that's our first equation. Let's go ahead and write our second equation. Second equation says we had a sub 10 equals 6561. Again, I have an n value and an a sub n value. So I'll plug in the a sub n value here. 6561 equals, plug in the n value in the exponent. A sub 1 times r to the 10 minus 1 power, which is 6561 equals a sub 1 to the r times r to the 9th power. So these are the two equations that I have created based on the information from the problem. That was step 1. Step 2 is going to be the same second step. It's to identify the pattern, but this time the variable for the pattern is r. And r stands for the common ratio, and a ratio is just a fraction. So if I'm trying to find the common ratio, all I need to do is make a big fraction to solve for this. And we're going to take the two formulas we had just a second ago, and we're going to put them in a giant fraction. And I want to make sure that the larger ratio, or the larger equation, goes in the numerator of this fraction. I want to take a look at my n value and pick the one with the larger n value to put in the numerator. So I'm going to take the one with the larger n value, 6561 is a sub 1 r to the 9th. That's going to go in the numerator. And the one with the smaller n value is going to go in the denominator. 243 is a sub 1 r to the 6th. Now that I've got those in a fraction, I will find r by actually dividing them. So let's divide these one step at a time. 6561 divided by 243 is 27. A sub 1 divided by itself is gone. They cancel. And if I have r to the 9th divided by r to the 6th, the 6 will cancel from the denominator, and I will only have r cubed left in the numerator. And now that I've finished dividing, I have an equation with just r, and I can solve for it by getting r alone. R is being cubed. It has to be cube rooted to find my answer. So r equals the cube root of 27, which equals the number 3. Now that we figured out what r is, my third step is exactly the same as it was last time. My third step is to find the other missing term by plugging r back in. And again, I can start with whichever equation I want to plug it back into. I made these two equations. I can pick either one of them to plug it back into, and the one on bottom is a little easier to use because the numbers are a little smaller. So I'm going to go ahead and take the equation 243 is a sub 1 times r to the 6th power. and I'm going to plug in the r value that I just calculated. And now all I have to do is actually solve this guy. So I'm going to start by actually doing r to the 6th power, so 3 to the 6th power. So 243 is ace of 1 times 729. And then to get it away from ace of 1, I'm going to divide both sides by 729. Divide, divide. So ace of 1 is going to equal this. And in the calculator it says 0.33333, which simplifies to 1/3. So now that we know what ace of 1 is, our job is going to be to answer the question. Again, the last step is just to go and make sure we read the question and know exactly what it's looking for. So this question is asking us to find the first 3 terms. So we are lucky, we already have the first term, ace of 1 is 1/3, and now all I have to do is find the next 2 terms. So ace of 2 and ace of 3. Now what I could do is create a general equation so I can plug in the number 2 and then plug in the number 3. And if that's what you want to do, you're absolutely more than welcome. The general equation again would be ace of n equals the first term, 1/3, times the common ratio, r, which is the number 3. We know that one now. Oh, thank you. Hello, blue pen. Thank you. All right, and then to the n minus 1 power, and I can plug in anything I want to. But the easier way, again, is to remember what a sequence means. To get from one number to the next, all I have to do is use the pattern, and we already found the pattern. The pattern is the number 3, and because it's a ratio, we just have to times 3 every time. So to get from 1/3 to the next term, I just multiply by 3, and I get the number 1. So ace of 2 is 1. Then to get to the next term, we multiply by 3 again. Ace of 3 is the number 3, and we're all done. We have the first 3 terms. We're going to pick up with finding partial sums in the next video.